Hello students, we are going to discuss about Unit 4, Chemistry of Fuels, and the subtopic is Ultimate Analysis of Coal. Now it is a quantitative analysis of coal where we can determine the elemental constituents like carbon, hydrogen, nitrogen, sulfur, oxygen and ash from the coal sample by chemical analysis method. Now first we'll be discussing about hydrogen and carbon, whereas the principle is like a known mass of or weight of coal sample is oxidized with the help of pure oxygen, and the carbon and hydrogens of the coal are converted to CO2 and H2O respectively. These CO2 and H2O are trapped using certain chemical traps like KOH and anhydrous CaCl2, where we can measure the weight of CO2 generated and H2O generated over there. And from the weight of CO2 we can calculate the amount of carbon. From the weight of H2O we can calculate the amount of hydrogen present in the given coal sample. Now here is the instrument used for the estimation of hydrogen and carbon both, whereas the coal sample is placed inside this platinum boat which is there inside this combustion tube. Now there is a pure dry oxygen inlet at one end where oxygen goes in and flows over this platinum boat. Furthermore, the boat is being heated with the help of flame from this burner. So carbon and oxygen present inside this combustion tube are going to react with each other to give you CO2. Same with the hydrogen, it will also react with oxygen to generate H2O. These CO2 and H2O are flown in forward direction by the incoming pure dry oxygen. In the furnace, basically the products moisture and the CO2, both of them are converted into pure gases which are flown down to the first U-shaped tube, which basically contains anhydrous magnesium perchlorate or anhydrous calcium chloride. This basically traps the moisture from the gaseous products. From the gaseous products, H2O is trapped and the remaining gases are passed on to the next U-shaped tube which contains KOH solution in it. KOH here basically reacts with carbon dioxide, gives you the K2CO3, potassium carbonate, a precipitate inside the tube, and the remaining gases are passed on in this CaCl2 guard tube where they will be taken care of or they will be trapped furthermore. Now the same procedure you can observe in this next 2-3 slides, like known weight of coal sample is burnt in a current of pure and dry oxygen in a combustion tube apparatus. Carbon and hydrogen are converted to CO2 and H2O respectively. The gaseous products are allowed to pass through first a pre-weighed U-shaped tube containing anhydrous calcium chloride or magnesium perchlorate. Basically it is going to absorb H2O vapors. Then the gaseous products are allowed to pass through a pre-weighed U-shaped tube containing KOH or lime soda, which will absorb CO2 over there. The increase in the weight of U-shaped tube containing CaCl2 basically will indicate the H2O generated in the combustion. Similarly, the increase in weight of KOH U tube indicates the weight of CO2 generated. Now the reactions in CaCl2 U tube, CaCl2 reacts with H2O, gives you CaCl2.7H2O. Basically the water is trapped over there as a water of crystallization for CaCl2. In case of KOH U tube, KOH reacts with CO2 generating K2CO3, a precipitate, white colored precipitate, and H2O over there. Now in this experiment there are certain observations before the experiment and after the experiment. Before the experiments, the observations are like weight of coal W grams, then weight of U-shaped tube containing anhydrous CaCl2 A1 gram, and then weight of U-shaped tube containing KOH, let's say B1 gram. Now once the experiment is done, after the experiment there are two observations to be done, like weight of U-shaped tube containing CaCl2, let's say after experiment it is A2 grams. Similarly, the weight of KOH U tube will be B2 grams. For calculations, we can have certain numbers, like weight of H2O generated is nothing but the increase in weight of U-shaped tube containing CaCl2, that is A2 minus A1, it comes out to be say A grams. Similarly, for CO2, increase in the weight of KOH is to be recorded, that is B2 minus B1, which gives you B grams. Now to determine percentage of hydrogen, weight of coal combusted was W gram, weight of H2O generated is A grams. So basically 18 grams of H2O corresponds to 2 gram of hydrogen present in the coal sample, W grams of coal sample. So 18 grams of H2O corresponds to 2 gram of hydrogen. Therefore, A gram of H2O corresponds to A multiplied by 2 divided by 18 grams of hydrogen. Now, for percentage of hydrogen, W gram of coal contains A multiplied by 2 divided by 18 grams of hydrogen. Then, 100 gram of coal will contain A multiplied by 2 divided by 18 multiplied by 100 divided by W grams of hydrogen. From this we can come up with the formula for percentage hydrogen, that is equal to 2 divided by 18. Here is nothing but A, the weight of H2O generated, multiplied by 100. Then here is the weight of coal sample W, which was taken for the initial experiment. So here is the formula for percentage hydrogen. Now similarly we can go for percentage of carbon, where again the weight of coal combusted was W grams, weight of CO2 generated was B grams. Basically it was the increase in the weight of KOH U-shaped tube. Now as from the reaction we can come up with the correlation, as 44 grams of CO2 corresponds to 12 gram of carbon, which was present in the coal sample. So if 44 gram of CO2 corresponds to 12 gram of carbon, then B gram of CO2 corresponds to B multiplied by 12 divided by 44 grams of carbon. Now this B gram of CO2 was there in the W gram of coal. So W gram of coal contains B multiplied by 12 divided by 44 gram of carbon. If W gram contains this much, how much will be there in 100 grams? So 100 gram of coal contains B multiplied by 12 divided by 44 multiplied by 100 upon W gram of carbon. Now from this we can come up with the percentage carbon formula like this. So percentage carbon is equal to 12 multiplied by 44 multiplied by this B, that is nothing but weight of CO2 generated, multiplied by 100 divided by W, that is nothing but weight of coal sample taken for the experiment. Here is the formula for that. So I'll stop here. This much is there in this first part. Remaining estimation of nitrogen and sulfur we will discuss in the next part of this same chapter in the further upcoming videos. Thank you.